Welcome to EPG Pathshala in Computer Science. This is a series of lectures in computer networks. So, we have been looking at a number of protocols with respect to the network layer. So, this is going to be one more to that list. So, we are going to look at support for mobile devices in IP. So, we are looking at mobile IP. So, we will look at the vocabulary of mobile IP. There are different terms that are used when we talk about mobile IP. We will take a look at that. And then you look at the operation of mobile IP and how these different IP services are provided in order to support mobility. Okay. So, we already covered a lot of topics about IP, forwarding, routing, multicast, etc. So, you can look at this as one last IP topic, mobile networking. So, what is why is this important? Because obviously, there is mobile networks all over, right? We are talking about mobile devices. In fact, I think mobile devices have started dominating the fixed devices, so wired devices. So, the number of mobile devices is much more. So, obviously, we need to be looking at how you can efficiently support mobile networks or mobile devices. What we also need to understand when we talk about mobile networking in the IP context is that we should not confuse this with portable networking. We can call a term called, we can coin a term called portable networking. So, when we talk of portable networking, what we are essentially meaning is that in a portable network, there is a requirement that you need to have connection to the same ISP. Okay, your cellular systems, for example, are examples of that. Okay, cellular system is an example of that, 3G, whatever. And Bluetooth also similarly, because again Bluetooth also you need to be connected to that particular network, right. So, it is a low cost short range radio link. Wireless Ethernet is your 802.11. So, there also you need to be connected to that particular Wi-Fi network. So, we are not talking about this domain of mobile connectivity, we are talking about an IP level mobile connectivity. Okay. So, what do we mean by mobility in this context from a network perspective? So, from a network perspective, if you look at it, at one end we have no mobility. It could be just a mobile wireless user, but using the same access point. So, that is considered as not mobile in the from a network perspective, because they are always connected to the same access point, always connected to the same network. So, at the other end, high mobility is you have a mobile user who passes through multiple access points while maintaining ongoing connections, almost like a cell phone. Okay. So, somewhere in between we can say you have a mobile user who is connecting and disconnecting from the network using DHCP. Okay. So, we have these three different categories of mobile users that we will need to support with respect to IP. Okay. So, now if you look at this kind of mobility and the standard IP routing that we have, what is the mismatch that we have? If you see that, now IP assumes that end hosts are in fixed physical locations. Okay. What we mean by that is that it addresses and the IP addresses, they enable IP routing algorithms to get packaged to the correct network using the network part and the host part, right. The network part is used to identify the network and then you reach the host using the host part. Okay. The host part would normally not be there in the routing tables, it is only the network part that will be there in the routing tables. Okay. Now, what happens when a user roams around is that this discrepancy of a network part and a host part, if I give an IP address to a mobile user which includes both a network part and a host part, now obviously when he goes to another network, that IP address will no longer be valid because he now has a different network part, right. So, that is one of the main challenges that we have with respect to handling mobility. Okay. So, and what happens if a user roams between networks? We want transparency. This routing information would become invalid, we do not want that to become invalid. Okay. And even while he is running an application, he may change the IP address. So, how do you handle that? Okay. These are all things that we need to handle when we want to support mobility. Okay. So, the mobile IP mechanism as such was developed as a means for transparently dealing with all these problems of mobile users. Okay. So, what it does is it enables hosts to stay connected to the internet regardless of their location and without changing their IP addresses. So, if I have got one IP address for my mobile, I use the same IP address wherever I go. Okay. That is the idea. And what is very interesting is that it really requires no major change or no changes to the software of non-mobile hosts and routers. You do not touch what is there as such, okay. But it requires addition of some infrastructure. Okay. There are no geographical limitations and there are no modifications to the IP addresses. Now, this is a very, very important aspect of how mobility is supported, right. So, we have a mechanism which allows supporting mobility in IP without really making any modification to the IP addresses, and it also supports security. Okay. So, if you look at the support that we have, there are certain terms that we use when we deal with mobility. Okay. So, we talk about something called a home network. Okay. Now, what is a home network? This is the permanent home of the mobile. So, this is the network to which the node is supposed to belong. Okay. It is home network. Okay. Now, this is a permanent address. So, this address in the home network can always be used to reach the mobile. So, if this mobile has an address of 128.119 or 140.186, wherever it is, whichever network it is, it will always have this particular address. Okay. So, you can look at it as a permanent address. Then we talk about something called a home agent. Now, the home agent is an entity which will be on your home network, and it is responsible for performing the mobility related functions on behalf of the mobile when the mobile is remote. When it is there in the home network, it just passes it to the to that particular node. Okay. So, home network, home agent, okay, these are two terms that we talk about. So, then we talk about the mobile node. The mobile node is the node that is actually moving from network to network, and it is assigned a permanent IP address, as we said, which is called its home address. That permanent IP address is called its home address. So, all hosts can send packets to this home address. Okay. Now, the home agent that we talked about just now, right, that is basically a router with some additional functionality. So, you can see that there is some additional functionality that needs to be added. So, it is a router with additional functionality. It is located on the home network of the mobile node, and it provides mobility binding of the mobile node's IP with its care of address. We will come to what this care of address is. Okay. There is something called a care of address that is used, and it forwards the packets to the appropriate network when the mobile node is away, and it will use some kind of an encapsulation or a tunneling mechanism to do that. Okay. So, certain more terms that we use. So, we talked about a permanent address. Now, we talked about a care of address, right. So, care of address is the address of this address in the visited network, that is, to which address should I send packets to when it is visiting some other network, like that is the care of address. Just as when we send mails, we sometimes say that you send it to somebody and say care of somebody else, right. So, that care of address is the person to whom you are delivering this, and that person will send it to the person that you are that you actually want the data to go to, or want your packet to go to. Okay. So, it is a care of address. So, this is your foreign network or a visited network. Okay. This is the network in which the mobile currently resides. So, that is called as a visited network or a foreign network, and the router at the foreign network, that is called as the foreign agent. So, this is the one which is responsible for the mobility functions on behalf of the mobile when it is visiting this particular network. Okay. And then we talk about a correspondent node. Now, this is the node which wants to communicate with the mobile. Okay. So, we have a CN correspondent node, MN mobile node, then we have a foreign agent FA, we have a home agent HA, we have a care of address COA. Right. These are some of the terms that I used. Okay. So, the foreign agent FA, what it is essentially another router with some enhanced functionality, and this is the one that is used to send and receive data between the mobile node and the home agent. Okay. So, it will advertise itself periodically to let a mobile node know that a foreign agent is present, and the care of address, this is the address which identifies the mobile node's current location, and it will be sent by the foreign agent to the home agent when the node attaches. We will look at these details a little shortly, and usually it is the IP address of the foreign agent, that is, the care of address is normally the IP address of the foreign agent. That makes sense, right, because you are visiting that foreign agent, so he takes care of you, so he gives you the care of address. And then there is a correspondent node, which we said is the host to which the MN is corresponding, right. So, that is a correspondent node. Okay. Now, so what is the basic problem of routing that we are actually trying to solve? Okay. When you want to deliver a packet to the mobile node, the first thing you need to do is figure out is how does the home agent intercept a packet that is destined for the mobile node. So, remember, the home agent is here connected to this network. So, a packet is coming to this mobile node somewhere here. Now, this fellow has to intercept that. Okay. So, first question therefore that comes is how does he intercept the packet? Now, mechanism which is as simple as proxy ARP can be used for that purpose. Okay. Second question is, how does the home agent then deliver the packet to the foreign agent? Now remember, when the mobile node is visiting another network, the packet has to be now forwarded to the foreign agent. So foreign agent can deliver it to that particular node. So how will you do that? How will the home agent send the packet to the foreign agent? That will have to be done using by sending it to the care of address, and it is done by means of setting up a IP tunneling. Okay, you have a tunnel set up between home agent and foreign agent, so that this packet can as such be tunneled through from the home agent to the foreign agent. Okay. Now how does the foreign agent deliver the packet to the mobile node? Okay, so that is the next step that you need to understand. Okay. So all these questions, how these are actually done, we look at this in detail now. Okay. So let us start with this basic question, how do you contact a mobile friend? Okay. So you have Bob here trying to find out where exactly Alice is. Okay. So what could you do? You could either search all phone books or call her parents, expect her to let you know where she is. Okay, these are things that you need to do, right? So how do we do it in a network? So in a network, there are two approaches that we could do. Okay, one, you can say let the router handle it. Okay, after all, routers are the ones which are supposed to know where the different networks are, where the nodes are. So let the router handle it. So the router could advertise the permanent address of mobile nodes, okay, in residence via usual routing table exchange. So when a mobile node gets connected to a router, its address is known to the router. So the router can also announce when it is exchanging its routing tables, it can announce the address of this node also. So that's a possibility. Okay. So after all, routing tables will indicate where each mobile node is located. We don't need to make any change to the end systems. We can just expect the router to handle it. This is one option. The second option is to allow the end systems to handle it. So if you allow the end systems to handle it, then there are two options there again. You can do something called an indirect routing, or you can do a direct routing. Okay, this is we will see how this is done. Okay, so indirect and direct routing. Now this first option of these, that is letting the router handle it, is not a feasible approach. It is not viable because it will not scale, especially when you have millions of mobiles. It will almost be like the router will have to give individual addresses. Individual addresses will have to be advertised by the routers. Now that will go totally against our whole philosophy of network address based routing that is done. Okay. So this is obviously not feasible. So what IPv4 does it allows the end systems to handle it. So it uses this approach of allowing end systems to take care of how the mobility is to be handled. Okay. So what are the support that IP provides in order to do all this forwarding of data and so on. Okay. So first is you need to know that there is something called a home agent and a foreign agent, and you need to know what their addresses are, right. You need to know the presence of the home agent and the foreign agent. So these agents, the home agents and the foreign agents, they will broadcast their presence on each network to which they are attached. So they keep sending out broadcast messages. Now the mobile node will listen for advertisement and then initiate a registration. It will register itself to that particular agent. Okay. So when the mobile node is on its home network, it registers with the home agent. When it is away, it registers its care of address with its home agent, okay, via the foreign agent. So which means it will first contact the foreign agent, and through the foreign agent it will contact the home agent and let the home agent know its care of address. Okay. And these registration control messages are normally sent via UDP to a well known port. And encapsulation and decapsulation mechanism will be used to send packets later from the home agent to the foreign agent. Okay. Okay. So now a mobile agent, what it will first do is it will listen for an agent advertisement and then it will initiate the registration step. If the responding agent is the HA, then we do not need any registration as such. If it is only when you are a foreign agent, you need to register. So after receiving the registration request from a mobile node, the home agent will acknowledge that request and complete the registration. Okay. And whenever the mobile node changes networks, a registration will have to be done, because every time you will have to register that you are now with a different foreign agent in a different foreign network. So that registration will have to be done every time. Okay. Now what the home agent will do is, remember the permanent address of the mobile node is that of the home network. So all packets when you send it to the mobile node's permanent address will actually be sent to the home address, home network address. So the home agent will intercept all the packets which are destined for the mobile node, because it will come to that particular network, so it will intercept it. Okay, and it will masquerade as the mobile node, which means it takes that packet, and then it will send the packet to the foreign agent, okay, to the care of address that is specified over here. Okay. Now there is also a specific lifetime before which a mobile node must re-register, because periodically you will have to refresh your entry basically, and when it returns home, that is when it comes back to the home agent, it will deregister, meaning that it is no longer with some other foreign network, but it has come back to the home network. Okay. So these are the things that will have to be done. Okay. So the home agent then, as we said, once it intercepts the packet, it will encapsulate all the packets addressed to the mobile node and forward it to the foreign agent using the tunneling mechanism. The foreign agent will decapsulate all the packets addressed to the mobile node and will forward them via the hardware address, which will be learned as part of the registration process, and give it to the mobile node. Okay. Now note that the mobile node itself can perform the FA functions if it acquires an IP address, for example via DHCP. Okay. And otherwise it will have to use it will be contacted by the foreign agent using its hardware address. Okay. And when you need bidirectional communications, then you will have tunneling in both directions. It will require tunneling in both directions, that is from HA to FA and from FA to HA. Okay. Okay. So let us look at these steps in detail. So first is the mobile agent discovery, okay, or the home agent and foreign agent discovery. So we said that foreign agents and home agents will advertise their service by broadcasting some message. What message do they broadcast? Basically an ICMP message. It is called an agent advertisement message. So you see this is your standard ICMP field that we have here, and then there is a mobility agent advertisement extension that is specified here. So here you will have a few bits which indicate whether it is home or a foreign agent which is giving the advertisement, and there is an R bit which says that registration is required, okay, and this will be followed by 0 or more care of addresses. A number of care of addresses can be specified depending on whether it is the foreign agent that is specifying it or the home agent or whatever. Okay. So you will have these details specified as part of this message. Okay. So now let us look at the registration process. Okay. So we have the home network here, some internet, wide area network, and this is another foreign network which our mobile is now visiting. So the mobile now will first contact the foreign agent on entering this visited network, okay, and this foreign agent now will contact the home agent, okay, will contact home agent saying this mobile is now resident in my network, okay. So once it does that, right, the home network now we can now talk back to the foreign agent, and the end result of this process, registration process, is that basically the home agent will acknowledge that registration. Once that acknowledgement is done, now the foreign agent knows about the mobile and the home agent knows the location of the mobile, because the home agent now knows that this is where this particular node is visiting. So we have this information. Okay. So the registration process as such, so you have registration request sent by the mobile node to the foreign agent forwards a request to the home agent. The home agent will send the reply, right, which the foreign agent will receive, and then it will forward it to the mobile node. So the registration gets completed. Okay. So when the registration is done, so this is you can see what the packets will look like. So this is your home agent, this is the foreign agent, this is the mobile agent. So the mobile agent is the first one that is going to contact the foreign agent. Okay. So let us say mobile agent, this is the address of the mobile agent. Okay. So now the first thing that will happen is an advertisement will have to come from the foreign agent. So foreign agent sends out an advertisement saying that the care of address is 79.129.13.2, which is the IP address of this foreign agent, let us say. Okay. So it gives the care of address. Now mobile agent on receiving this advertisement, okay, is sending a request for registration saying this is the care of address, this is my home address, because you have to say which is your home agent address, right. This is my home agent address, this is the mobile my address, okay, and then what is the lifetime, for how long this registration is supposed to be valid, okay, and give some identification. So this now will be forwarded by the foreign agent to the home agent. So what is the information that it is giving? So now it is forwarding, it is saying I am sending it, care of address is this is the home agent address, this is the mobile agent address, okay, and it will encapsulation format. What is the format that will be used for encapsulation, that is specified, and it is sent to the home agent. Now the home agent will send a registration reply. So the reply will say, okay, it is acknowledging that information. So it gives the home agent address, the mobile agent address, okay, and that again now will be forwarded by the foreign agent to the mobile agent. So this completes the mobile IP registration step. Okay. So now once the registration is done, so we talked about two types of routing, right, indirect routing and direct routing. So we will take a look at the indirect routing now. So what happens in this indirect routing? So when a node, a correspondent node which wants to communicate with the mobile node, it sends a packet, it will send it using the home address of the mobile, which is the permanent address of the mobile. So that packet will go to the home network. Now the home network, you have this home agent which is sitting here, it will intercept this packet, right. So it will intercept the packet, and since this node has already registered itself, right, it knows what is the foreign agent where this particular packet, where this particular node is now located. So it will intercept the packet and forward that packet to the foreign agent, okay. So through the network to the internet, it forwards it to the foreign agent. The foreign agent now, it receives the packet, okay, and it will send it to the mobile. Now when it is sending it from the home agent to the foreign agent, when the packet is being sent, this step 2, it is encapsulated and sent. So encapsulation will take place here, decapsulation will take place at the foreign agent, and the original packet will be sent to the node. Okay. This is what is called as indirect routing. That is, the correspondent node does not directly contact the mobile node, but it goes through the home agent. So it is an indirect routing. Okay. Subsequent to this, once the packet has been sent to the home to the mobile node, now the mobile can do a direct reply to the correspondent. Okay. So now this will be able to send direct replies to the correspondent. So now this is how the process will get completed. Okay. Okay. So, so we saw that the mobile will therefore use two addresses. One is the permanent address, which is used by the correspondent. Okay. Hence the mobile location is transparent to the correspondent. He does not know exactly where he is located. He only uses the permanent address. And then there is a care of address, which is used by the home agent to forward datagrams to the mobile. So there are two addresses that the mobile will use. Okay. Now the foreign agent functions may be done by the mobile itself. Okay, that is also a possibility. But one of the problems we have with this indirect routing is that you can end up with something called a triangle routing. That is, let us say for instance, okay, that is between the correspondent, home, network and mobile, right. So this triangle, that is every time correspondent has to send it to the home network will send it to the mobile, and then the mobile is going to talk to the correspondent node directly. Now this can become very inefficient, especially if the correspondent and the mobile are in the same network. Look at this situation. Okay, let us assume that this was the home network, okay, the left one, and this is our visiting network, foreign network. Assume that the correspondent node is actually in this network. Now what will happen, though the correspondent node is in the same network, when he wants to contact our mobile node, the address he has is that of the permanent address, which is this address, the address of the home network. So the packet that he is sending from here, from this network, will go all the way to the home agent which is located there, and from the home agent it will get forwarded to the foreign agent back to the same network, and from the foreign agent it will be delivered to the mobile node. Okay. So this you can see is a very inefficient delivery. Okay, this is something that we try to avoid. Okay. That is one thing. Now suppose a mobile user moves to another network. We have the same indirect routing, but let us look at what happens when the mobile user moves to another network. Now he will register with the new foreign agent, right, because he will now be in another network. That foreign agent will send a advertisement. So he will see that advertisement and he will register with that new foreign agent, and the new foreign agent will register with the home agent. Okay. So the home agent now will have to update the care of address for the mobile, because earlier it was with some other foreign agent. Now it will move to some other foreign agent. So that updation will have to be done at the home agent. Then once that is done, the packets can continue to be forwarded to the mobile with the new care of address. Okay. So now during this process, right, the correspondent node will not even be aware of the fact that the mobile node has actually moved from one network to another network. Okay. So this mobility and changing of foreign networks is transparent. This is a major advantage. Okay. And your ongoing connections can be maintained. Okay. This is a major advantage when we are doing this kind of an indirect routing, because it is the home agent that is always taking care of forwarding things for you. right? It is acting like a post office. So, it is forwarding things for you. Since it is doing that, it becomes easy to take care of this mobility in a very transparent manner. Okay. So, now in this process there is obviously there is some information that needs to be maintained, right, at the routers. So, at the HA, okay, we have something called a mobility binding table that will be maintained. Okay. Now, what will be the information that you have in the mobility binding table? The home address of the node and the care of address, where exactly it is, and the lifetime, that is for how long this entry is considered to be valid. Okay. This basically maps the MN's home address to its current care of address. Okay. And then there is something called a visitor list, which is maintained at the foreign agent. So, the foreign agent will have to keep track of who are all visiting it. So, it will map the visiting node, that is the mobile node's home address, to its MAC address and also to the home agent's address, because it needs to know which is the home agent that it needs to contact. Okay. So, the home agent address for it to contact, and similarly the MAC address of this device, so that it can forward packets to that particular device, right. So, you can see that in this situation the mobile node which is visiting a particular foreign network is not given any new IP, right. All its packets are being sent only to the foreign agent, that is the care of address. The foreign agent will use the MAC address to send the packet over here, that is the key over here. Okay. And the sending of packets, we said, it gets done by means of IP tunneling. So, that is the home agent will take the packet, right, and the corresponding node sends a packet to this. So, it receives a packet. Now, the packet that it receives as such is put into another IP packet. This IP packet will have source address as home agent and destination address as care of agent. This encapsulated IP packet will come to the foreign agent. This fellow now will remove this, get the original IP packet and send it to the mobile node. Okay. So, you can see how the tunneling gets done. So, the correspondent node is here, sending with this destination to this permanent IP address. So, our home agent now will pick up this packet, add the care of address, destination address, care of address is 79. This, which is the foreign agent address. Okay. So, it will add this address, send this packet to the foreign agent, and the foreign agent now will remove this address and send the destination address it knows is 128.119. For this address, for this mobile node, it knows the MAC address, it will forward it to that network. Okay. So, one of the problems that we talked about with this indirect routing was this triangle routing, that is the suboptimal triangle routing that you have, that is the one that we talked about, right, where the mobile node and the correspondent node are actually on the same network, but the home agent is somewhere else. Okay. So, actually it would be nice if we could directly route the packets. Okay. So, how can we do that? So, this is possible if you let the correspondent node know the care of address of the mobile node. So, then the CN then must be equipped with software to enable it to learn the care of address, and initiated by the home agent, which can notify the CN that this is a binding update, that you will bind this address hereafter to this care of address. So, it is almost like saying that you will keep track of this binding, and you can use the care of address to forward the packets to this particular mobile node. Okay. Of course, the binding table can become stale because the mobile node may move. So, you will have to send the binding updates frequently whenever there is a change. Okay. Okay. So, now this we call as a direct routing mechanism. So, so when you do direct routing, let us look at what happens. So, your the first step is your correspondent requests the home network and receives the foreign address of the mobile. So, the home address actually sends the information to the correspondent node, and the correspondent node now will talk to the foreign agent directly. Okay, 3, and this fellow now can respond, mobile now can reply back to the correspondent directly. Okay, this is called as a direct routing mechanism. Okay, so now this direct routing mechanism obviously will overcome the triangle routing problem, especially an inefficient triangle routing problem, and both of them are in the same network, because it knows that the foreign agent is right there on its network. So, it can directly send it to that particular node. Okay, that is definitely an advantage, but the disadvantage is that it is non-transparent to the correspondent, because now the correspondent must get the care of address from the home agent. So, the correspondent node now has to do more work. So, it has to know that it is talking to a mobile, therefore, it should know that it has to go and talk to the home agent, get the information of the care of address from the home agent, and then it will have to forward the packet. So, more work to be done by the correspondent. Okay. Now, what if the mobile changes the visited network? So, what will happen in that case? So, you will have to accommodate for that mobility also. So, what do? we talk about something called an anchor foreign agent. Okay. So, that is the foreign agent in the first visited network, okay, that is called as the anchor foreign agent. So, let us say this was the first visited network. Okay. So, now the home agent has given this address of this anchor foreign agent to the correspondent agent. So, the data will always be first routed to the anchor foreign agent, and if the mobile moves, okay, mobile let us say moves from this network to this new foreign network here. So, what the new FA will do, the foreign agent will do is, it will arrange to have the data forwarded from the old foreign agent. So, you can see what will happen here. So, correspondent agent will send it to the anchor foreign agent. Now, since this fellow has moved, then node now, mobile node will now contact the new foreign agent. The new foreign agent will talk to the anchor foreign agent, okay, and inform it of its address. Then the anchor foreign agent will send the packet through the new foreign agent to this network, to the mobile node. Okay. So, this is how you can take care of mobility with direct routing also. Okay. So, another support that we talked about with respect to mobile is in IP is that support for security, right. Security is supported by making sure that all this communication that you have between mobile node, between the home agent, foreign agent and so on, okay, is all done in an authenticated manner. Okay. So, authentication can be performed by all parties. Only authentication between MN and HA is required. Keyed MD5 is the default mechanism that is used. Replay protection is also taken care of. Remember, replay attacks are possible. So, that is prevented by making timestamps. Okay, you will normally have a timestamp that is sent with all the packets, and random numbers on request reply packets are optional. So, that can be used as some kind of a check, right, a challenge response kind of a thing. Okay, and the HA and the FA, they do not share any security information. So, this is basically what is done. Okay. And we have support for mobility in IPv6, which is because route optimization is almost a fundamental part of mobile V6. Now, in V4, we actually have an optional set of extensions that may not be supported by all nodes, but in V6 it is a default. And we do not need foreign agents as such in mobile IPv6, because the way IPv6 addresses are assigned, okay, that is irrespective of the location. So, mobile nodes can function in any location without the services of any special router in that location. So, V6 has a natural support for mobility. So, that becomes an added advantage when we move to V6 networks. And V6 anyway has support for security. So, that security also becomes available for mobile nodes as well. So, you can see that when we move to V6, you have a lot more support and efficient organization for mobility. Okay. So, to summarize, so what we have looked at in this lecture, we have looked at basic support for mobility in IP networks. We looked at the terminology that we use, foreign agent, home agent, correspondent node, care of address and so on. We looked at the registration process, how that will get done. We looked at how the routing and forwarding gets done. We looked at a direct routing and an indirect routing mechanism. So, with this understanding of IP and mobility, you should be able to figure out what happens actually when you are sending packets to laptops which are moving from one place to another. Thank you.